Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to recognize the relative position of rational numbers on a number line, how to compare rational numbers and order them from least to greatest, how to recognize all numbers as being part of the number system, to determine which number set within the number system a number belongs, to recognize that numbers can belong to multiple number sets at the same time, and to recognize closure of number sets within the number system under mathematical operations. How are we learning it? Through the relative position on a number line notes and relative position on a number line assignment, as well as the infinite set closure part 2 notes and the infinite set closure part 2 assignment. When can we use this? To develop mathematical organization skills that allow you to organize budgets, use relative numbers to split checks and determine the cost of sale items, and to perform simple calculations such as a budget by recognizing boundaries of numbers to determine if adding the items in your budget will stay within your income amount. How do you know you learned it? By getting a score of 4 on the relative position on a number line assignment and 4 on the infinite set closure part 2 assignment. Now let's take a look at our agenda for today. We'll begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you're done with your Get It Started, we'll go over it together and answer any questions that you may have. Then we'll do our weekly raffle. After that, we'll go over the relative position on a number line notes, and then you'll complete the relative position on a number line assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your homework for tonight is to complete the infinite set closure part 2 assignment, to continue working on the reasoning with rational numbers study guide, and any incomplete assignments that you may have. Let's take a look now at the infinite set closure part 2 notes. Our notes begin with the learning goals and success criteria. Now let's talk about the definition of infinite set closure. First of all, what does infinite mean? Infinite means an uncountable number of elements. So it goes on to infinity. It keeps going forever. So an example of this would be like the natural numbers. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we can keep counting. And no matter what number we stop at, there's always a number past it. So that's an infinite number of elements. Therefore, an infinite set means that we cannot count the number of elements in the set. The opposite of this would be a finite set in which there are a countable number of elements. So let's say I wanted the natural numbers between 1 and 10. Well, that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and stops. And we can't keep going. So that would be a finite set. So an example of an infinite set would be the set of integers. So there's no limit to the number of integers we can count. Now, closure definition. What does closure mean? Closure under an operation means a set is considered to be closed if when that operation is performed on any two elements within the set, the result is also in the set. Okay, note that this must be true for all elements in the set. If there is even one case where the result falls outside the set, then it is considered to be not closed. Okay, so let's take a look at what this means. So here's an example. We have the set of -1, 0, and 1, and want to know, is it closed under addition? So what that means is I'm going to take each of these elements, so like -1 and 1, and when I add them together, I get 0, which is in the set. So that means that the set might be closed. If for some reason, though, I end up adding two numbers together, and the result is outside the set, so let's say I add something together and I get 6. Well, 6 is not in the set, so therefore it is not closed. So an example of what would make the set closed would be -1 plus 1 equals 0. Because 0 is in the set, it looks like it might be closed. Now, is there an example we can come up with that makes it out of the set? Well, if we add 1 plus 1, because we do need to include it plus itself, so 1 plus 1 equals 2. Well, 2 is not in the set, therefore the set is not closed. And again, if there's even one example of this, so it doesn't matter that this part ended up inside the set. Because this one example is out of the set, then the whole set is not closed. So now let's take a look at this infinite set here, the set S of integers, and what we want to know is it closed under addition. Now we can't use a table anymore, So we need to think of some examples of addition of integers and then try to broaden it and say, is there any way that any two integers can be added together and not be an integer? So we do some examples here, and we can see that they're still turning out to be integers. So is there any way we can add two integers together and not get an integer? So if I add any two negative integers, is there any way to get a fraction out of it? Is there any way to get a real number out of it? Is there any way to get a complex number out of it? Well, no, there's not, right? Anytime I add any two whole numbers together, I should get another whole number. So therefore, there is no way to add two integers together without getting another integer, so therefore the set is closed. Now what about this? The set S of integers closed under division. So again, we're going to think of some examples. So we have 2 divided by 1, 1 divided by 2. Notice here though, when we do 1 divided by 2, we get 1/2. Well, 1/2 is not an integer, that's a rational number. So therefore, when we do it that way, we know that it's not closed. Now, there's an easier way for us to be able to tell that this set is not closed. Because I told you last time, if we include 0 in the set, then it is never closed under division because it's undefined. So if we divide something by 0, it will always be undefined. So 0 is an integer, so if we were to divide a set by 0, it would be undefined. So therefore, that previous set would not be closed because of division by 0. Now what if we said the set of rationals excluding 0 is closed under division? Well, again, we're going to think of some examples. So we have 1/2 divided by 1/4 is equal to 2, and negative 1/2 divided by 1/3. Remember, really, it's just multiplying by the reciprocal. So is there any way we're going to get something other than a rational number, other than a fraction? Well, we keep thinking of some examples, and when we keep looking, we can see that there is no way, and we did exclude 0. So we know that 0 is not an issue, so we don't have to worry about dividing by 0. So therefore, we can just look at these examples and continue to come up with more examples, and we can see that the set is actually closed because no matter what, when I divide two fractions by each other, I will always get another fraction. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the Infinite Set Closure Part 2 assignment. Our assignment begins with our learning goals and success criteria. If we scroll down, there's a link here that'll take us to the Desmos activity. When we click on that link, it takes us to a page that looks like this. We're going to go ahead and click Start the Activity. The activity begins with our learning goals and success criteria. We'll go ahead and click Next. And then it says, decide whether the set of rational numbers Q is closed under subtraction. If it is not closed, provide an example of when the set would not be closed. So what we're going to do is we're going to decide whether it's closed or not. So in this case, we're going to say that it's closed. So therefore, we don't need to come up with an example. Let's look at this one that says, decide whether the set of rational numbers Q is closed under squaring. Now let's say it's not closed. Then we would need to provide a counter example. So for instance, like 1/2 to the second power is equal to, and we know that that's 1/4, which in this case is still in the set. But we would provide an example here in this box if the set is not closed. So you would mark closed or not closed for each of these. If it's not closed, provide an example in the box. So you'll do that for each of these two slides. Once you're done with those two slides, you'll go back to your Google form, click Next. This will take you to your before you go Go ahead and fill out the before you go and then submit your work on Google Classroom.